We are now solving three different exam questions about the Poisson distribution. The first question is this question 6. This is from June 2008, paper 7. And the question tells this. People arrive randomly and independently at the elevator in a block of flats at an average rate of 4 people every 5 minutes. First question is, find the probability that exactly 2 people arrive in a 1-minute period. Okay, first thing for you to check. What is the interval that we are looking for in this particular question? It's a 1-minute period, so this is an interval. What is the information that we are being given? It's the number of people arriving every 5 minutes. Okay, so we have to put this in terms of the time interval that we want, which is 1 minute, which is obviously very easy. We have basically 2/3. Let me see if I'm in the right place. Yeah, 2/3 of people arriving per minute. Let me check. No, I'm in the wrong question. Yeah, this is it. We have 4 people arriving in an interval of 5 minutes. So this gives us 0.8 people per minute. So if we want to calculate the probability that exactly 2 people arrive in a 1-minute period, we first define what our random variable is. X is a number of people arriving each minute. So our parameter is already defined, is 0.8. This is the average of people arriving per minute, the time interval that we want. So we just need to calculate the probability that x equals 2. We just need to apply the formula that you learned in lesson, this one over here, in which lambda in this case is 0.8 and r is 2. Just apply it in a calculator and here you have the result. Okay? Question 2. Find the probability that nobody arrives in a 15-second period. Now the interval has changed. It's no longer 1 minute, it's 15 seconds. 15 seconds, as you know, is a quarter of a minute. So we first need to define our new parameter. It is no longer going to be 0.8, it's going to be a quarter of this. It's going to be 0.2 people for every 15-second interval. So we have our second random variable, which is a number of people arriving in each 15 seconds. And now, well, this is defined as a Poisson distribution with parameter 0.2. And now we need the probability that x2 equals 0. Again, just apply the formula. And here you have it. Question 3 is a little bit different. It tells you already that the probability that at least one person arrives in the next t minutes is 0.9. Find the value of t. Okay? Now we already know the probability. We don't know the interval. We need to calculate it. Okay? So let's translate this sentence from English to math. And what does it say? Obviously, the random variable is going to change. This is going to be now the number of people arriving in the next t minutes. Okay? The first one was for 1 minute. The second one was for 15 seconds. Here, the interval is the thing that you need to calculate. So it needs to be a different random variable. You know that probability that x3 is bigger or equal to 1 is 0.9. This is what the question is telling you, right? The probability that at least one person arrives in the next 10 minutes is 0.9. At least one person, x is bigger or equal to 1. And this is 0.9. All right, if x3 is bigger or equal to 1, this is the same as 1 minus the probability that x3, I forgot to put the 3 there, is 0, right? You already know this from last year. You know that the value for this particular probability is 0.9. So the probability that x equals 0 is 1 minus 0.9, so it's 0.1. You just apply a formula now, and you leave lambda as the subject. You don't know the mean yet. That's what you're going to calculate. All right. You should know already by this time from Pure Math 3 how to work this out. Just apply natural logarithms to both sides, and you find the value of lambda as being 2.3 people. All right. But that's not what you want. What you want is a time interval. But you know, since the beginning, that there is an average of 0.8 people per minute. So if you got 2.3 people, then to calculate the time interval, just multiply this by t being the time, okay? So t is going to be the average, which is 2.3 divided by 0.8, and here you have the time interval. I forgot to underline the final result as usual in green. So there you have it. Okay, let's go to another paper. This is November 2005, and it's question 6. It tells you this. A shopkeeper sells electric fans. The demand for fans follows a Poisson distribution with mean 3.2 per week. Find the probability that the demand is exactly 2 fans in any 1 week. Okay, so here the interval matches. You have the mean in this interval, which is 1 week. The question regards also the same interval, 1 week, so this is pretty straightforward. X is the number of fans sold per week, so can be expressed as a Poisson distribution with parameter 3.2. The probability that X equals 2 is calculated using the formula, and just plug the values in, and here you have the result. Pretty straightforward, basically free 2 points. Question 2. The shopkeeper has 4 fans in his shop at the beginning of a week. Find the probability that this will not be enough to satisfy the demand for fans in that week. What does this mean? This means that if the shopkeeper is not able to satisfy the demand, it means that he would need more than 4 fans, right? So what you are being told is, or to calculate, is the probability that X is bigger than 4. As you know, this is 1 minus the probability that X equals 0, X equals 1, X equals 2, X equals 3, and X equals 4. So I paused here the calculation to make the individual calculations for the probabilities over here. And what is this? I just applied here this method that simplifies the calculations every time you have recurrence relations. This allows the use of the term obtained previously to work out the next one. So imagine that you're calculating the probability that X equals 3. If you already know the probability that X equals 2, all you have to do is put here the parameter, the mean, divided by 3 times the probability that X equals 3 minus 1, which is 2, that you already have. So basically that's what I did over here. I started with the probability that X equals 0. Here you have it. So the probability that X equals 1 is the parameter divided by 1 times the value that I already calculated. Here we go. Then for X equals 2, the parameter divided by 2 by the previous probability, that one, and so forth. Note here that I expressed the probabilities with 4 significant figures, because these are intermediate calculations, not the ones that you need. You are going to now to plug all of these in these places. That's what I have over here, so that at the end I can confidently express the final result with 3 significant figures as the mark schemes demand. Question 3. Given instead that he has n fans in his shop at the beginning of a week, find by trial and error the least value of n for which the probability of his not being able to satisfy the demand for fans in that week is less than 0.05. Okay, not a simple question to translate, but let's look at it with more detail. He has a certain number of fans in his shop, and you need to calculate the probability that the least value of fans sorry, let me read it again. Find the trial and error, the least value of n for which the probability of his not being able to satisfy the demand for fans is less than 0.05. Okay, so you need to, what you know is that the probability that x is bigger than that value n is smaller than 0.05. See how this long sentence can be translated into something as simple as this? You want to calculate the probability that the number of fans sold in that week is bigger than a certain number, knowing that this probability is 0.05. Right? So this is 1 minus the probability that x is smaller or equal to n. And from the above, you know that when n equals 4, when it has 4 fans at the beginning of the week, the probability that x is bigger than 4, we already calculated it, is 0.219. Well, this is bigger than the 0.05. So this is the point where you start using the trial and error. You know that n is not going to be 4, okay? We already know that this is bigger than what they are being asked, so let's try 5. So you apply the same method, okay? But here it doesn't end in 4. You have to include here the probability that x equals 5. That's what I did, okay? I already have all of these calculated, all right? It's 0.781. That's what I put over here. I just included the probability that x equals 5. I used the method. So 3.2 divided by 5 times the probability that x equals 4, which is that. I already included here in pink the values that I'm going to need later, all right? This is 0.105, is still bigger than 0.05, so we need to go to the next one, n equals 6. So same thing, I have to include now over here the probability that x equals 6, but I already have all of that, okay? All of that from 0 to 5 is this value. I put it over there. And I include the probability that x equals 6, so 3.2 divided by 6 times the probability that x equals 5, which is this over here. And this gives 0.0442, which is smaller than 0.05. Okay, so what is the value of n? By trial and error, it's 6. If it has 6 fans, then the probability that he will not meet demand is going to be smaller than the 0.05. Another question. Winter 2010, paper 71, and the question is question 2. People arrive randomly and independently at a supermarket checkout at an average rate of 2 people every 3 minutes. 2 people every 3 minutes. Find the probability that exactly 4 people arrive in a 5-minute period. Okay, so the interval that you are looking for is 5 minutes. The information is given in terms of with an interval of 3 minutes. So let's fix that very quickly. So the information that you are given is 2/3. That's going to be the people arriving per minute. So multiply this by 5, and you have the number of people arriving in every 5-minute intervals is 10/3. You are being asked to calculate the probability that exactly 4 people arrive in a 5-minute interval. Now that you know the parameter for 5 minutes, it's 10/3. You just apply the formula for x being equal to 4, okay? Formula, result. All right, at another checkout in the same supermarket, people arrive randomly and independently at an average rate of 1 person each minute. Find the probability that a total of fewer than 3 people arrive at the 2 checkouts in a 3-minute period. Interval is 3 minutes. This 3 minutes. This one is given in terms of each minute. Okay, so we have to put here in the interval that the question is asking. You have 2 checkouts. The first one is already in terms of the interval that you want. Okay, so let's make this in terms of 3 minutes, and then we're good to go. So 1 people arriving per minute, that means obviously that you have 3 people arriving per 3 minutes intervals in checkout 2. In checkout 1, you have 2 people arriving per 3 minutes intervals. The question told you this at the beginning. So the total number of people arriving in these 2 checkouts in the supermarket is 5 people arriving per 3 minutes interval. Okay, so here you have the parameter. The random variable is going to be the number of people overall arriving per 3 minutes interval. And you want to know, let me check again, total of fewer than 3 people. Okay, so probability that xt is smaller than 3, that is equal to the probability that xt equals 0 plus 1 plus 2. Okay, so let's go ahead and calculate it using the method that I mentioned before. You have here all the probabilities, add them together, and here you have the overall probability.